Hi everyone, this is our first question from Analog Electronics. Here is the question. Assume that the diode has V on is equal to 0.7 volts, but it is otherwise ideal. We are required to find the current I2 which is flowing through the 6 kilo ohm resistor. Before we proceed, let us look at the prerequisites. So to understand this problem, we must know the voltage division rule. Consider a voltage source of value V volts having two resistors R1 and R2 connected in series to it. Then the voltage developed across the resistor R1 is given by V1 equal to R1 dot V by R1 plus R2, and the voltage developed across the resistor R2 is given by V2 equal to R2 dot V by R1 plus R2. Next we arrive at the diode. Let us consider the positive side of the diode to be the anode denoted by capital A, and let the N side of the diode be called the cathode denoted by capital K. Next, we need to know the two important tests to analyze any diode, which are open circuit test and short circuit test. In the open circuit test, we assume that the diode is off and calculate the potential difference between the anode and the cathode, opening the diode. So, the potential difference is called VAK. If this VAK is greater than V on, then the diode is said to be on. And if the VAK is less than or equal to V on, then the diode is said to be off. Here the V on is, is the cut-in voltage of the diode. Next comes the short circuit test. In this we assume that the diode is on and we calculate the current flowing from the anode terminal to the cathode terminal when the diode is short circuited. If this diode current ID is greater than 0, then the diode is said to be on, and if the diode current ID is less than or equal to 0, the diode is said to be off. Now using these prerequisites, let us solve the question. Now first I will be doing the method 1, which is using the open circuit test to calculate the current I2. First let us start by taking the reference voltage, which is the ground, 0 volts, and since this is a 2 volt voltage source, the voltage at this point can be written as 2 volt. This is the anode of the open circuited diode, and to calculate the voltage at the cathode of this open circuited diode, we need to know the voltage developed across this 6 kilo ohm resistor. So in order to find that, we can use the voltage division rule. So the voltage developed across the 6 kilo ohm resistor is as follows. V at 6 kilo ohm is 6K by 6K plus 2K multiplied with the voltage source, which is 2 volts. All these Ks get cancelled. So the voltage at 6 kilo ohm resistor is 12 by 8, which is 1.5 volts. And it is given that V on is equal to 0.7 volts. Since the cathode voltage is 1.5 volts, the potential difference between the anode and the cathode is VA, which is 2, minus VK, which is 1.5 from the figure, which is 0.5 volts. Now it is clearly seen that the cut-in voltage of the diode is greater than the potential difference between the anode and the cathode. So as VAK is less than V on, as per the prerequisites, we can say that the diode is off. So as this is the open circuit test, our assumption that the diode is off is actually correct because we are proving the same by solving this. Now as this is the open circuit, zero current flows through this part of the circuit, so that part of the circuit can be neglected, and this current I2 can be found using Ohm's law, which is I2 equal to the voltage 2 volts divided by the two resistors in series, which are 2K plus 6K. This value is 0.25 milliampere. So this is the current flowing through the 6 kilo ohm resistor. Let us do the same question using method 2, which is the short circuit test. In the short circuit test, I have taken the diode to be shorted, and since this is a practical diode with cut-in voltage mentioned in the question as 0.7 volts, we are supposed to take a voltage source of value 0.7 volts in series with the short circuited diode. Now let us consider the Kirchhoff's current law at this particular point and check whether the diode current ID is a positive value or a negative value in order to confirm our short circuit test. So applying KCL at this point, so this is the point. So this current is ID, which is flowing downwards. This is a 2 kilo ohm resistor. I am taking this as the ground, which is the reference voltage, 0 volts. Since this is a plus minus 2 volt and this is the ground, this point will be minus 2 volts. So this is the 2 kilo ohm resistor. This point is 0 volts. Let this point be X. And this X is, as this is the ground and this is the 0.7 voltage source, this X is 0.7 volts. To be accurate, it is minus 0.7 volts. So the voltage at this point is 0.7 volts. The current arriving from the top is ID. And below we have a 6 kilo ohm resistor with the downward voltage as minus 2 volts. So applying the KCL, the current ID equal to minus 0.7 minus 0 by 2K plus, see this current ID is equal to this current in addition with the downward current. So the downward current is minus 0.7 minus of minus 2 by 6K, which is ID equal to minus 0.7 by 2K. This is minus into minus is plus. 2 minus 0.7 is 1.3. So this is 1.3 by 6K, which is this 1.3 by 6K is 2.16 into 10 power minus 4. And this minus 0.7 by 2000 is minus 3.5 into 10 power minus 4. Now the exact magnitude of this current is not of much use to us because we can clearly see when minus 3.5 is added with the 2.16, the ID current is clearly negative. That means the current flowing from the anode to the cathode of the diode is negative. That means we have failed the short circuit test. So this is the conclusion. Our assumption that the diode is on is incorrect. Therefore, since our assumption that the diode is on is incorrect, so the diode is off. Since the diode is off, this entire circuit can be considered as an open circuit, and this becomes exactly like the previous method. So the current flowing through the 6 kilo ohm resistor is I2 equal to the voltage divided by the series resistance of the resistors R1 and R2, which is 2K plus 6K, which is 2 by 8K. We arrive at 0.25 milliampere. So through both the methods, we have arrived at the same answer. So the final answer of this problem, as asked in the question, is the current I2 flowing through the resistor 6 kilo ohm is 0.25 milliamperes. Thank you.